Hello and welcome to this Connected Site webinar series from Leica Geosystems. I'd like to thank you very much for tuning in to this webinar series where we're going to take you through a journey on the construction process. Where it falls with this conversation is around understanding 3D space, and at the end of the construction process and at the beginning, how do we understand the facilities management element of it using dynamic 3D capture. Or reality capture as it's called, from Leica Geosystems. So I'll just introduce myself. My name's Steve Cairns. I've got at least 20 years experience in the geospatial industry, and I've been with Leica for nearly 5 years in various roles from support, marketing, and in recent times I've been working on consultancy for dynamic reality capture projects. And I'd also like to introduce a guest speaker today. So we've got Alex Harvey from River, so that's reality and virtual reality. So I'll just like to say hi, Alex, how's it going?
Hi, Steve. Yeah, really good. Thanks for having us on. And I guess a bit of my background was back in Codemasters days when I sort of started my digital world. I was there for 10 years making racing games, and then we moved into making production videos and promotional videos for different companies, and now we are fully deep in 360 and room scale VR.
Sounds really good. Thank you very much for coming on to talk with me about through this. I've got really good stuff lined up. We're going to talk about what Alex is doing a bit later in this webinar. So I'll just quickly introduce Antonio. He's not talking on our webinar, but he's the UK and Benelux reality capture sales consultant. He's also got 20 years experience, and he's been with Leica the same as me, 5 years, so we're almost one-to-one. So I'll just give you a brief rundown of our agenda. So what I want to talk about is understanding this 3D space. So, you know, really there's practically unlimited benefits really of taking a 3D picture in time. So I just want to cover 3 elements. So, you know, when we've got time and space is at a premium for all of us, having that scan first mentality. So if I go somewhere, I'm taking an instrument with me, or I've got access to it, like the camera you take with you is the best one. You know, why come back with nothing when you can come back with 3D? So we want to talk about why it's vital to be prepared, optimize the space that you're within, so getting the best quality of data, and how that can use for such elements for VR and planning and 3D storyboarding. And that's where Alex will come in at the second half. So we're going to talk to Alex about situational training for VR and what they're also doing with our technology as well. So some really interesting projects that I've seen Alex working on recently. And then we're also going to talk about some projects with our own customers. So York University data with the backpack, how that's facilitating a high level of facilities management. And at the end, I want to talk about some of the other projects that we've been working on in terms of understanding heritage, for example. So I'll just kick off with the first section of really, before we get to the use case, but what technology we're talking about. We're talking about dynamic reality capture. So there's lots of different technologies out there that could be brought in, you know, even from a mobile phone size up to something that you put on a vehicle. But I want to focus in on the 2 real, you know, the wearable or things that you can hold in your hand. So these are really realistic items that you could take with you. So here we've got the Pegasus backpack and also the Leica BRK to go. So the backpack is a wearable reality capture instrument. It's a true mobile mapping. It's got a device. It's got GNSS, so we've got high precision positioning on the Earth, a high resolution camera array, and that's coupled with LiDAR. So we're measuring the 3D of what's around us. And that's all coupled to an IMU as well. So we're getting unfolded 3D as we walk forwards in time. So that's a really fantastic for the large to medium-sized projects. But when we don't have to deploy that all the time, how do we get the use of an instrument that we can hold? So wherever I am, I can infill sections of data. You don't have to rescan everything all the time. You can scan little sections of it. So we've recently launched a new product, which is a handheld mobile mapping device, and that's working on LiDAR capturing the environment around it, and its positioning technology is based on SLAM. So that's an algorithm that positions itself based on its environment, and that's called simultaneous localization and mapping. So that's packaged into this technology. It's not a separate download or an algorithm you have to do post-processed. It's all real time in the hands. That's a very important point with this scanner.
I'm always amazed as well, Steve, with the form factor of the new scanners. From looking back through the last sort of 4 years where we've been involved, the form factor's got completely tiny. Like, we've been to lots of the Leica events, and I'm always interested to see their next products. The BLK, like we'll talk about later, has definitely changed things for us.
So really, in the first part, after we've discovered the technology, I want to talk about how that if we are there capturing buildings, if sometimes we need to translate that image to the eye, to a person, how is the best way to do that? And I think if we take, cross-sectional, like traditional drawings, they don't really sing or they don't leap off the page and give you a true sense of that actual building itself. So in the interest of we capture, we're also painting 1,000 words effectively about this type of building. It's a well-known phrase, but if you do need to capture all of those 1,000 words about a building, then how do you do that? And how do you translate that to somebody who has no idea about that 3D space?
Well, I think that when you can spatially experience these places in a 3D model, even on a 2D screen, then you're halfway to completely understanding the space like you would in the real world. Obviously, we can talk about it in a bit, but the next step would be to get these into a virtual scene to be able to look around them. Spatially viewing stuff is so beneficial for people to understand what that space was like.
Yeah, I think, and exactly that's when you can actually plan the spaces of a building. So how do people move through a building in terms of its footfall, like the design? So when you're capturing the reality of these, why wouldn't you capture them in the way that they were to be designed to be used? When you're talking about the actual shape and the volume of the air in the spaces, and Alex was talking about capturing the dynamics of the air in the space as well. That's really important for his business.
Yeah, we had some clients recently asking us to come and scan their hospitals. So obviously we spoke to Leica about that, and yes, these things are possible because they want to know how many people they can fit in the space, for one, after post-COVID stuff, and also how the air and bacteria and things might flow around that building. So if you've got a fully accurate model of that space, then that's the perfect starting block. The more up to date that data is, the better as well.
I totally agree. So just go to a bit of a use case as well. So what you're looking at here is a project that was captured with the backpack at Heathrow. So this was an example of an international company working to understand airports, not just them as where they are, but also what the building space is inside, for floor plan management, for changing elements of it, for actually designing the flow of the functionality of how people exist inside the building as well.
And I mean, imagine seeing this from a floor plan point of view. That would, for me especially, I would be much more confused about looking at that floor plan than I was looking at the image that they're shown on the screen. Yeah,
completely. And one of the kind of spin-offs, if you could say, in all of these progresses in computer vision learning and image and pixel analysis, part of the fact that if you're capturing the highest quality of data at the point of when you've captured it, then the pictures themselves can also lead into certain things like, you've got artificial intelligence of image learning algorithms. So the true concept of GIS, where someone would have to go and manually asset tag all of these objects, we can learn where they are from the data that we're capturing. So not just we understand the 3D, but where is all the objects inside it as well. And I think that's really important.
I think that's a good. Well, that highlights a feature with your latest technology. You know, the technology now is not just a laser or a point. You're now capturing the laser data as well as capturing imagery. You know,
Yeah,
and
exactly.
fusing those two together. It seems like that's the way things are going to go.
Yeah, definitely. And that is in here. I just want to show you a quick example of a data set that was captured on behalf of a Heathrow project. And here you could quickly understand the apron side, you know, the air side part of this airport for the transitioning of larger objects like aircraft. You can see here I'm seamlessly going between 3D and image, but, you know, also planes are not buildings, but they're almost as big as, so we need to understand what, you know, how they're moving around as well.
And Steve, was this scanned with the roof-mounted system?
It was, yeah. So it's mobile mapping on the top of a vehicle and driven around to
And for
capture.
the inside of the building, was that the Pegasus backpack?
Yeah, so that was exactly. So the backpack was combined with there to build up the picture in 3D as well.
It looks amazing, yeah.
And here's just a few screenshots from our software. You've got the approach to Terminal 5 passenger drop-off departure there as well. So that's completely captured, photorealistic. You know, you can see where all those assets are. So in terms of future algorithms for positioning vehicles in this 3D world, they can also understand how vehicles move around as well, you know, this in terms of autonomy.
Well, Steve, tell me how long it took to do the scan, like the car scan, for example, because it just makes me think about why would you not be scanning, you know, as much as every day in the future?
Well, that is a very good point on an asset like this. This type of project took 1 day to actually complete, and within that day, it was about 6 hours of driving around.
Okay.
So yeah, to capture all the land and the air side, you looked at about a day of capture, which is, you know, you're looking at it, it's near to an impossibility of doing that traditionally.
Yeah, definitely.
So we've understood a bit about the technology, and now really just want to talk more in detail about how do we understand the inside out of a building. So we enter a building, we start measuring it, we're free to move forward in 3D space, but then once we've done all of that, you know, what happens to this? How does this data become a kind of, you know, a useful element or an asset to the people that are providing to them? So as you can see here, this is at York University. There's a project that's been ongoing for many years now where, you know, they want to be world leaders in facilities management on a campus of a university. So they want to be adopting latest technology, you know, high resolution pictures and LiDAR at the same time to create, yes, it's a graphic on the right, but it just shows you, if I go to the next one, the true appreciation of that space in terms of planning as well.
Oh yeah, this looks amazing. So this would be great for comparing, I guess, the plans of this building to how it was actually built in real life.
Yeah, absolutely could be. That's exactly another good point as well. If you've got how you want to validate against the construction process as it was being built, and also its life cycle. You know, these buildings will have a certain anticipated lifespan, and we can experience that throughout time. So it's almost its history is being logged as every time you scan it.
Yeah, I love the way it's so accessible now to get to this result.
Yeah, it is really a key part of everyone. You know, the everyone part of this as well is really changing the way you can capture. So just a bit of a breakdown on the actual technology itself. Here I'm just looking at our software from Leica's point of view. We've got our Cyclone family, so we've got the 3DR element and the Register 360 ortho tools. So I can do cross sections within the registration software of the LiDAR data, or I can do it later on as part of an analysis. So, if I'm looking at the data and meshing it, for example, to create a model, I can use some tools in 3DR, for example, to give me a noise reduction. And in Register 360, I can also create smooth surfaces. So they're very powerful tools for getting a good cleanliness and a quick, rapid floor plan in this example.
Yeah, God, the floor plan example brings me back a few years, like 4 years ago when we were doing property videos for high-end estate agents. We had a guy that was literally doing it the traditional way with a, disto and writing down on a bit of paper the measurements of the floor plans, then sending them off overnight to be made into a plan. This looks like you could just walk around and do it within about 25 minutes.
Oh, or less. Here we're looking at a 2-bedroom flat, and I think, to be honest, with this type of walking around, you're capturing the actual real spaces, not just between the rooms, but between the walls as well. When I bought my house, yeah, exactly. My floor plan was missing half of a room because it is just someone's approximation. And all of these mistakes cost either people not looking at that property on the website. So I think more than ever now, virtual floor plans and such things will be prevalent as we move into the future.
Quick and accurate data. It looks awesome.
Yeah. So this is just an example of in our modern times now, with what's been going on over the last few months in terms of the way that we're changing socially distancing. Even in our the retail world will have to come back with a cohesive plan. How do people go back to supermarkets and position themselves safely within not just the general public, but also the people that work there? So this is, again, the backpack empowering that type of technology and data to deliver those answers relatively quickly.
It's a bit of a side note, but it looks amazing how it seems to have picked up the mannequins in the shop windows.
Yeah, it's spraying out about it's about 360,000 points a second per scanner. So it's really, you're going to get a high fidelity on it, and the way that you use these types of data as well to get the best visualization out of them as well is to put this into our 3DR software, where you can then create an ortho image as well. So what you're looking at here is 1 millimeter per screen pixel per image, and that's what gives it this crisp, kind of almost artist sketchbook type approach.
Yeah, it looks like a really dense cloud, and the people in the windows look like artistic sketches that are actually to scale. So it does look really good as well.
It's impressive. It always knocks me back when I see the data in the backpack presented like this.
Yeah, it makes me want to zoom in and spin things around.
Yeah, well, that we can do, in our processing. And this point of here is, we saw buildings earlier from York University. This is one of the 3 buildings that I captured with Met Geo Environmental. So as part of the York University project, they wanted to understand the building internals, but also the relationship with what they sit like on the campus and the traditional topographical surveys. So here you're seeing everything rolled into one. So in terms of health and safety, facilities management, and even planning escape routes and such things, this data is absolutely vital for that.
It looks super detailed as well. Yeah, this is the sort of thing that we talk about with when we've been in America talking to like Department of Defense. They're always talking to us about how can we rapidly scan areas, for current threats or events that might be happening. And look, just for example, this would give you the complete view from one of those windows on the left if you needed to zoom in. Yeah, I can see the value for that.
Exactly, like a vantage point or a view from one window to the other.
Yeah.
Instantly you can do that with this type of data. So we've seen quite a lot of example there of the dynamic reality capture, and really I just want to press a little bit on the workflow. It is the most important part of actually doing and getting to the answers that you've seen previously. So here on the left, we've got sort of what I'd say is a bundle of dynamic reality capture tools from some of our static reality capture has IMU. So it is a it's it's not quite static. It's in between dynamic because it's sensitive to its inertia as it's moved around. So these tools are feeding into a reduced amount of software tools now. Because we've brought some of the process together. So the Pegasus Manager Suite, for example, handles the data from the backpack. And in the same way that the Cyclone Register 360 also handles the data from the BLK to go and the Register 360, and the also works with the BLK 360. So bringing all that data together means that I can package it to a cloud and share, instead of individual files, I'm starting to share places of 3D data like Jetstream. It's a vault where data goes, and it gives me accessibility to give that data out to it can be client facing all the rest of my organization.
And I think that's going to be important for Leica as they look at different areas that might find this sort of technology useful, like our industry for virtual reality. I imagine that's not the main focus of Leica's business, but I've found the workflow to be really handy. Like, I can do it when I've been. We had the BLK to go, and I was working with the workflow for the data, and I was surprised. I could do it. I was expecting it to be confusing, but it wasn't.
No, it has got down to the point now where it feels like it's kind of an app driven. You've got import, inspect, check results, export. It really is. It's a step by step, and if you've got button press on the instrument, you've got almost close to button press with some functionality that's required. So yeah, it was amazing when I gave it to you, Alex, that within about an hour you'd come back and said, "Oh, I've scanned this, and here's the data. I've exported it."
Yeah, here's my house. I've just done the whole house.
Yeah, perfect. So that brings me to the end of what I was talking about for the understanding the space. What I want to talk about now is how Alex and River have been, on a journey of 3D and capturing spaces in ultra high realism for different industries. So I'll just pass over to Alex, who can talk you through what he's been doing and what River are all about, and using some of our tech.
Yeah, cool. Thanks, Steve. We've obviously been creating virtual reality for sort of maybe the last 3 years, but we've been tinkering with the laser scanning for quite a bit longer than that, as we've been working on different projects, Steve. But the main focus that we've been using it for recently, the laser scanning technology, is for our photorealistic interactive virtual reality training scenarios that we've made for the fire service. So we basically got ourselves a site in Kenilworth where we arranged to do 6 controlled burns with different fire investigators that gave us their insights into the way that training's done currently. And just briefly, at the moment, they burn the containers in the real world, and then they bring students in to look around the burnt scenario after the fire's been put out, to try and work out what the cause of the fire was. But they're not allowed to pick everything up and move the items too much because they've got other students coming through that day. So I just thought that's a perfect thing for us to try and create in a virtual environment. But it was always key to me to make sure it was always photorealistic, which is why we use photogrammetry. But we wanted to have a base for the photogrammetry to basically align to, like a puzzle, for us to replace the items after we've scanned them. Because the scene was burnt, we had to take out individual items one by one and scan them in a photogrammetry rig next door to the burn container. But to give us that initial where everything was, if you like, we used the RTC 360. And Steve Ramsey, thanks again for one of the videos that he came and helped with here. So yeah, as we play this video, this is us using the RTC in one of the burnt scenes, and we scanned it before the burn and then after the burn, and then we removed all the items one by one, and then the guys in post had a really accurate model, because we wanted to make sure that all of the items that we placed back were in completely the same location as they were before we moved them. It was always a bit dodgy to move these items because some of them can fall apart. So it was really nice to be able to put them back on their spots.
Yeah, that's a really interesting, and I know when we talked about this before that using that scan, like, because I know you were struggling to see, like, I think why you'd use it. You know, you could just use the high resolution photogrammetry, but then the before and after part to get the real, like, you know, the actual high precision measurements would make that massive difference.
Massively. It gave us the super accurate location of all the models, yeah, before and after.
Amazing.
Okay, so as we moved on in our journey of photogrammetry and different assets, this is something that we worked with Capture in Reality, where we use their software for all of our photogrammetry. So this was testing a new rig. If you see in the video, there's 6 DSLRs that we designed, or Ross designed, to be on this rig, so that as you walk along taking your photogrammetry, you now don't have to do 6 passes of one wall with your camera and tripod. You can now walk along and do 1 pass, and it has he's made sure that overlap is correct, so that
So
it
these are
really
calibrated
does,
then as
yeah,
well.
it
Okay.
really does help with the photogrammetry when we feed all the images back into reality capture. We also use some drone in this one, and this model can now be viewed in VR. This is now textured. It's quite high poly, but we can see it in VR. We can blow it up. We can make it small. And spatially viewing it again is absolutely amazing. On this project, we didn't use a laser scanner. This was purely just testing the photogrammetry rig. And yeah, I think it was probably in about 1,200 images. And the plan in the future is, as you see, the castle, Kenilworth Castle and Warwick Castle. We would like to be able to scan those environments. Warwick Castle is quite complete, but Kenilworth Castle's been a lot of it's been destroyed. So we would like to rebuild those areas based on the detailed laser and photogrammetry data that we can collect on site.
Yeah, I think that would make a big difference to, if, like, probably the time on site isn't going to reduce for the photogrammetry, but probably to just understand, like, what's there and the amount of work that you'd have to, say, 3D storyboard before you went there would, with the intent to capture everything, would be absolutely critical for these type. When you have more projects, I think, that you need to manage.
100%. Like we were scanning something else recently, and we used the BLK to send off first into this big building to have a look at the data, because there were so many dark corridors. We couldn't go down and quickly photogrammetry those areas, so we just sent. Well, Steve, you came with us to another site and went down and did some BLK capture in these dark tunnels, so
Yeah.
that we can look at that data now and go, okay, if we're going to PG and photogrammetry down there, what would we need to do? We can see the size of it, the length of it. Yeah,
You could even work out how many pictures you need to take down there as well, probably in the future.
Yeah, because you might know that 1 meter might take 50 photos. Yeah, exactly.
Awesome. Well, that's a really good overview of that. And I know in recent times, Alex has had a BLK and he's been using it for a few other things. So I'll let you explain.
Yeah, so if you want to press play on this video, this one, I did some phone capture on the left. So you're seeing on the left the iPhone capture, and on the right, it's just the capture from the cyclone. I was amazed at how high it got. If you look on the left here, look at the top of the buildings. I wasn't expecting the BLK to go up and get the top of those buildings. So this was literally me parking up and just walking the street. And then I moved on to the windmill, the Chesterton windmill, did the same. On the left, you see the capture, and on the right, the cyclone. And this was my first time in the software. So I was learning it as I was going along.
You'd had it like an hour, I think, after I gave you this.
Yeah, I was addicted. The windmill came out very well, but I needed to do the top of it. But obviously I couldn't reach.
Yeah, we'll have to get the drone out for that.
And then this was me, because we were on lockdown, this was actually a dog walk. So I was walking along with the dog, and I took my rucksack with the BLK, and I saw this old barn. I thought, this is perfect. So The dog got quite annoyed as I just walked around this a few times, but it was perfect, right in the middle of a field.
It looks
Amazing.
amazing. It's captured the corners of that and the thickness of the stone perfectly.
Yeah, I had to cut
Like
a
I
bit
say,
off
but
because it
this is
actually got
complete.
the
Yeah,
it had me walking up to it as well.
complete testament to, like, if you're there, as I said right at the start, you've got accessibility to take this back with you. There's no way that you could capture this in any other way in the current times with
Definitely.
such a portable instrument.
It wasn't like I had to have an extended walk. This was just like a walk and I had it in my hand. It was
Yeah,
amazing.
amazing. So if you brought that into a VFX or a computer game, like if you were creating a situation where, for a game, and you plonk that in, then you could bring it in and it would be realistic, like the lean and everything, like the actual the feeling of that building would be able to be captured. I think that's, instead of it being like everything geometrically accurate, it's too sterile. It needs to be more realistic.
Oh, if you tried to model that for a computer game, yeah, it's going to take you ages and it's not going to look as real.
Yeah,
It's
look,
so authentic to get the geometry down, and then I guess the artist can go to work on the
yeah,
texture.
yeah. Once they've just got the basic outline,
Yeah, and that was
great.
the end of
So
that. That's that video. I'm not sure what was it. Okay, okay. Now we move on to a
the
different.
future, this one was, I remember we.
This is definitely going into the future. So, looking at projects going forward, past fire investigation and crime scene investigation, which we're creating as well for the UK police. This is high-rise virtual reality procedure training for the fire service. So, after Grenfell and lots of incidents with high-rise, we had access to this empty high-rise in Rugby. So Steve came along with the RTC 360 and we did photogrammetry and drone and laser. And what you're seeing here is inside those flats. So we worked out that if we laser scanned, I think it was maybe 3 flats inside, we could basically duplicate each flat and make the whole building.
Yeah.
And I think you also did the ground floor, the whole of the ground floor.
Yeah, I did something like, I think it was 45 setups on the entire downstairs floor of like 11-story building. I did that on, well, it took me a couple of hours, but yeah, it was like, that was the most, in terms of everything else wasn't replicated. Everything above that floor, as you just said, will just be a 1 or 2 bedroom flat, if that's right.
Yeah, there's the different combinations of flats on different floors, but the idea for us, the outcome, the end goal, is to have a virtual reality asset that allows the fire service to do training on every procedure that they might do at a high rise. And there's a whole national occupational guidance document now, which goes into super detail about all the new ways that they should be handling these buildings. So we're basically turning that into a photorealistic virtual reality asset for people to use. And we're going to talk about it more and show some more demos in September, as long as the conference is going ahead. There's a high-rise conference where we'll have this in a headset and you'll be able to stand outside the flats, look up, go onto each floor, look at the dry riser, make sure everything's in as it should be. But and also have the ability to do like search and rescue through every room, fill every room with smoke. The amount of things that we're going to be able to do with this asset are amazing, just from having access to it for like a couple of days.
Yeah, I think this will be a complete classic example of, people say capture things, use many times, but how many things do we capture and use that often? But I think in this instance, scanning this like that, it was well worth the time, because it will just you can generate so much from this. And every time you think of a new avenue, bring that data in and you can do something else with it. It's really incredible.
Yeah, repurposing flats for many other of the virtual reality scenes that we've created for the UK Home Office. They've also repurposed those assets. So there was actually a Leica job where we did a crime scene investigation scan. We used the P50, I think, with 4D Max back in the day.
Yeah.
And that model got used for 3 different purposes, 3 different types of training. They just repurposed the flat.
Brilliant. Well, it's really good to hear that, because that's always been one thing, is where laser scans get discarded or misused, or just misplaced or not used again, and because they are, as we said at the start, like a capture in time of 3D space. It really, as you said, this building will be knocked down in a couple of months, so it's gone. So no, I don't think anyone else will have this level of complexity like that you've got access to. So it's really special.
Yeah, I'm excited.
Cool. Well, to be honest, I think that brings us close to the end of this webinar. But I just wanted to finish on, really just pushing the idea that if you are there and you've got these types of technologies now, I think mobile mapping in the hand, we can create, as you're looking at this Bath Abbey here, this type of fidelity of data this was a 3 to 5 minute walk. So this is a classic example of being somewhere where, I was there for other reasons. I was having a meeting, but I was able to capture that data, because I had the luxury of doing so, because I had the scanner with me. And I hope, in the future that will become more and more accessible to everybody.
It looks amazing from that scan. It looks amazing how high, again, like I said earlier, how high that laser, from a layperson's point of view, you got really high. Like you were just walking through, and it seems like it was as accessible as almost having your phone in your pocket.
Yeah, exactly that. You look up, like those vaulted ceilings are about 21 meters. You're starting to get on the edge of it, which is, I think from the hand, you're measuring, hundreds of thousands of points from that one as you're holding it, just walking around. So it actually captured quite a lot of people's attention in there, because they were saying, what are you doing? And we said, oh, I'm just capturing it. But think of it like a survey, maybe, might make sense. So they just had no concept. You look at what you captured on the phone and they're just mind blown. So.
It's like the Google Maps at the moment, when if you go into Google Maps or Google Street View, and you can scroll back through the years of different 360 images.
Yeah.
It seems like in the future there will be a scrollable 3D, of every place.
Yeah. No, it's really interesting. So yeah, well, I hope that you've enjoyed that. Again, thanks to Alex for joining me from River. I've enjoyed talking about understanding 3D space. And as I said, this is part of another set of webinars. So please go and experience the other stages as well. And I wish you all the best. Thank you very much for attending. So thanks, Alex.
Thanks, Steve. Yeah, good to chat, and I'll speak soon.
Okay, thank you very much. Cheers.